Hi, today I'm gonna prove that the area of a circle, okay, is pi r squared because everybody knows that the area we learned in school that area of a circle is pi r squared. But where does this come from? Okay, I'm gonna prove it with calculus through integration. So we're just gonna integrate the first quadrant with respect to y. Okay, so we're gonna make one here, then another one here, and keep going and keep going, keep going till we fill this whole area, and then we're gonna multiply by 4. All right. Now, you guys are gonna see that the first way of doing this doesn't work. First of all, if you want to integrate with respect to y, okay, now what's the value going to be here when y is 0? What's the value going to be? It's going to be r, okay? Well, it's not a vector. What about here? What is going to be this length right here? When y is at this point, what's going to be the length? It's going to be x, okay? You can see that it's always been x. When y is at this point, it's going to be this x right here. That's the length. When y is at this point, meaning when the value of y is r, the value of the radius of the circle, x is 0. Okay, so you can think about this as an integration of x, which is just x. Okay, it's going to be this x plus this x plus this x all the way to r with respect to y from 0 to r. Okay, great. This is not going to, well, it's the initial idea, okay, but it's not going to work, and I'm going to show you guys why. So we have to integrate this, but we have to relate x with respect to y. Now, what is x in a circle? Okay, we're going to consider that this here is the origin, the point 0, 0 in the Cartesian plane. So, well, what's the equation of a circle? X squared plus y squared equals r squared. So x, in this case, I'm just going to consider the positive x because we're just talking about the first quadrant here. So it's going to be the square root of r squared minus y squared. So we have to integrate with respect to this, okay, with respect to this thing here. The reason that's not going to work, I'm not going to start doing this because I'm going to show you guys why it doesn't work. Okay, what is this thing here? This thing here is the same, okay, I'm just going to put it here. It's the same as r squared minus y squared to the 1/2 because it's a square root, okay? So what are we going to do now? Well, we have to integrate this with respect to y, right? Because it's y here, so it's y here. Okay, great. So let's do it. We have to increase this, the power by 1, and then I have to divide. So it's going to be r squared minus y squared to the 3/2 because it's 1/2 plus 1 divided by 3/2, meaning it's multiplied by 2/3. Okay? And then you have to divide by the inner function because you have an outer function. Okay? The outer function is just this square root right here. But the inner function is this one here. Let me see. Okay, here we go. That's the inner function. And you have to divide the whole thing in a chain rule by the derivative of the inner function with respect to y. Okay, now what is the derivative of r squared with respect to y? Well, that's 0. And then you have a minus, so we know that's going to be a minus here. And the derivative of y squared with respect to y, which is 2y. So you have to divide this whole thing by 2y, but it's already being divided by 3. So we're just going to get this 3 out of here, and we're going to put a 6y. Now, what is the problem? Is that you're going to have to derive from 0 to r. That means that at some point, this y right here is going to be 0. So you're going to be dividing this part, the numerator, by a 0 denominator, and this just doesn't work. Okay, this doesn't exist. This whole thing here does not exist. So we're going to have to do something else. I'm going to erase this stuff. I'm going to get a larger brush in here. So what are we going to have to do? Is that we're going to have to relate x and y with theta. Okay, we're going to have to use trigonometric functions to take care of this thing. So what is x, okay, with respect to theta? I'm just going to put a, I think that I'm going to put it over here. What is x with respect to theta? X equals r cosine of theta, okay? Y equals r sine of theta. Great. And now we also need to use, because we're going to plug in this x over here. See, over here, okay? So we also need dy. See here, we need dy. So let's just do dx and dy. So dx is going to be equal to the derivative of cosine of theta with respect to theta is minus sine of theta. So this is going to be minus r sine of theta. And dy equals r cosine of theta. Okay, now we have this thing here. So we're just going to use these functions over here. Okay, I'm going to transform this into the integral. That'll be x, so it's going to be r cosine of theta. dy, what is dy? R cosine of theta, so we just get r squared cosine squared of theta, okay? Now, you're going to be integrating along y here, okay? And when you do that, what you see, when you start using trigonometric functions, you're not just going to add a bunch of x's in here. What you're going to do is that you're going to add this vector plus this vector plus this vector plus this vector plus this. You're going to be filling the whole thing, all right? So the vector is going to have to go from 0 degrees all the way to 90 degrees over here, all right? So instead of varying, because now we're integrating with respect to theta, so instead of going from 0 to r, we're going to have to rearrange the limits here, which is from 0 degrees all the way to pi divided by 2. Okay, d theta. Okay, that's going to be the new variable of differentiation. I'm going to erase this stuff in here. Okay. All right. So let's do this here. Well, the r squared is just just a constant. R is never gonna change. Okay, R is never gonna change. So we can check it out of the integration. So I'm gonna go all the way here. It'll be r squared, the integral of 0 to pi divided by 2. Okay, of cosine squared of theta with respect to theta. Now, that's not going to work either. Why? Because you see what you have here is a squared, okay? And this squared over here is going to be the outer function. The cosine is the inner function, but the variable is d theta. So the variable is related to the inner function. The variable of integration is related to the inner function, not to the outer function. So in order for this to work, you would have to do substitution like u equals cosine of theta, okay? And the outer function was going to be u squared. So integrating this was going to be u cubed divided by 3, and you have to divide it by du. For this to work, you would have to have a du over here, but you don't. What is a du? Well, if u is cosine of theta, a du is going to be minus sine of theta. Do you have minus sine of theta here anywhere? No. So this is just not going to work. Okay. So what I'm going to do is to use, instead of using an outer function and an inner function, I'm going to use identities to one trigonometric identity to transform this cosine squared of theta into a cosine powered to the first power. It'll be a cosine power to the first power, okay? So there's a trigonometric identity that says that cosine squared of theta equals 1 plus cosine of 2 theta divided by 2. You see that I got rid of the second power? Now I just have a power of 1 here, okay? So I'm just going to integrate with respect to this. So here we go. It's just going to be 1. And I'm going to separate the fractions too because it'll be easier. It'll be 1 divided by 2 plus the cosine of 2 theta divided by 2 d theta, right? We're gonna do this here. We're not gonna need this thing here anymore, so well, I don't know if I need to erase this. I'm just gonna continue down here. So we have an r squared, and now we're gonna integrate this, okay? We're gonna integrate this, so I'm just gonna put it here. What's the integral of half with respect to theta? Well, it's just gonna be theta divided by 2 plus the cosine of 2 theta, the integral of this is going to be the sine of 2 theta, okay, divided by this 2 here, but hold on a second, because you also have to divide by the derivative of the inner function with respect to theta. What's the inner function? 2 theta. So what is the derivative of this? It's 2. So you're going to divide by this 2, and you have to divide by this 2. So you're dividing the whole thing by 4. Not that it matters, because this whole term here is going to be 0. And we're going to see that in a second. So there you go. And you have to just replace now the theta here from 0 all the way to pi divided by 2. So we're going to do that now. So it's going to be r squared. What a horrible r. R squared, okay? That's multiplying. Well, you got pi. You got theta, and you're going to replace pi divided by 2 into this theta. So it's pi divided by 2 divided by 2. So it's pi divided by 4. Pi divided by 4. Okay, plus the sine of 2 times pi divided by 2. So this thing here is going to become pi. And what is the sine of pi? The sine of pi is 0, so this becomes 0, okay? And now you have to subtract, right? You got to plug this 0 into the thetas here. So what is 0 divided by 2? Is 0. Minus sine of, when you plug the 0 into this theta, it's just going to be the sine of 0 again, so the whole thing is going to be 0, okay? So what do you have? We have the result of all of this. The integral, this area, this entire area here, is what? R squared times pi divided by 4. Okay? There you go. Now, you want the area of the entire circle. So what do? You multiply this by 4, right? So you multiply this by 4. These two cancel each other. They simplify. And what are you left with? Pi r squared, which is the area of the circle. And there you go.